Alright, so we're going to be talking about particle motion. Again, your position function can be written as s of t or x of t. Sometimes they'll write y of t if it's on the y-axis. They write x of t if it's on the x-axis. Your velocity is the derivative of your position, which is v. You're familiar with that. Your acceleration is the second derivative of your position function, or the first derivative of your velocity. And you're also familiar with your a. And so when we talk about displacement, we're talking in physics, you're talking about the distance between your y-coordinates at A and B. So you want to take the antiderivative of v of t, which gives you s of b minus s of a. That gives you your displacement. Your total distance, you want to make your displacement positive in all increments, so we're going to do the absolute value. If you want to find the position of a particle at a certain time, so s of b, which is at position at a certain time, you're going to do your starting point, which is s of a, plus your displacement. Alright, for number 1, we're going to find a of 3, v of 3, and s of 3. So a particle moves along the x-axis with a velocity at time is greater than 0, given by v of t is equal to negative 1 plus e to the 1 minus t. At time equals 0, your position is 2, so that's your starting point. So if we want to find our acceleration, a of t is going to be the derivative of my velocity, which is e to the negative 1 minus t, and then I need to take the derivative of my exponent, which is negative 1. So my acceleration at 3 is going to be negative, again that's where the negative 1 came from, e to the 1 minus 3, which is negative e to the negative 2. Now if I want to find my velocity at 3, I can just plug in. And so I can just plug in the formula they gave me, which is negative 1 plus e to the 1 minus 3. So that's going to give me negative 1 plus e to the negative 2, or I could write this as negative 1 plus 1 over e squared. Our position function, we need to take our antiderivative. So if I want to find s of 3, I need to do my starting point plus my displacement. And so s of 0, which we knew from the beginning, is 2 plus, and I'm going to split this guy up, 0 to 3 of negative 1 dt plus zero to 3 e to the 1 minus t dt. This guy right here, I'm going to use u substitution because I don't have a simple e to a function, or I have e to a function. It's a little hard to see what my antiderivative is going to be. So I'm going to let u be the exponent. Du is going to be negative dt. My u of a, let me do it this way. I'll do a sub u. I'm going to plug in 0 into this function right here. So 1 minus 0 is equal to 1. My b, I'm going to plug in 3. So 1 minus 3 is equal to negative 2. So 2 plus, so I'm going to go ahead and take the antiderivative of this guy. The antiderivative of negative 1 is negative t, evaluated from 0 to 3, plus, and then this one's going to be my u substitution. So my new b is my new a is 1, my new b is negative 2, e to the 1 minus t d, excuse me, not e to the 1, e to the u times negative 1 times du. So this gives me 2 plus, and so this gives me negative 3 minus 0 plus antiderivative of 1 to negative 2 of negative e to the u du. And so when I simplify this part right here, I'm going to get negative 1 plus, and so now let's take the antiderivative. So this gives me negative e to the u, evaluated from 1 to negative 2, which is negative 1 plus negative e to the negative 2 minus negative e to the 1. So if I simplify this, these become positive. I have negative 1 minus 1 over e squared, that's the negative 2, plus e. And there's my position. Alright, number 2, is the speed of the particle increasing at t equals 3? Give a reason for your answer. So when we talk about increasing, that means both that my acceleration and my velocity have to have the same sign. If it is decreasing, that means my acceleration and my velocity have opposite signs. So we talked about this before. So we want to check. So 1 over e squared, this number is very close to 0, so it's kind of like saying negative 1 plus 0. Well, that means this is a negative number. You can see from a of 3 that this also is going to be a negative number. And so since my acceleration and my velocity are both negative, that means my speed is increasing. So speed is increasing because both acceleration and velocity are negative. Alright, number 3, find out the values of t for which the particle changes direction. Justify your answer. So when we talk about changes direction, you need to find where is it the first derivative, or where your velocity is equal to 0. And so we need to find what values of t make the velocity equal to 0. So I'm going to set my velocity function equal to 0. I'll add 1 to both sides. And so now if I want to be able to get to the exponent, I need to take the ln of both sides. So the ln of 1 is equal to the ln of e to 1 minus t. Again, according to log rules, if I have something raised to a power, that means it comes in front. You learn that in Algebra 2 and pre-cal. So this gives me 1 minus t ln of e. Ln of 1 is equal to 0. Ln of e cancels, it becomes 1, so I'm left with 1 minus t. If I add t to both sides, I get t is equal to 1, which makes sense because when I plug in 1 into my velocity function, I'm going to get negative 1 plus e to the 1 minus 1. Well, this becomes negative 1 plus e to the 0. E to the 0 is positive 1, so it does make sense that negative 1 plus positive 1 is equal to 0. Alright, number 4, find the displacement and total distance of the particle over the time interval from 0 to 3. And so what I'm going to do is I'm going to show you through using the calculator. I'm going to use y equals. And so my function is negative 1 plus e to the 1 minus t, or in this case 1 minus x. And my displacement is from 0 to 3, so I'm going to go to window, and I'm going to change x min is 0, x max is 3. And I'm going to go from negative 3 to, let's say, positive 3. I want to zoom in, because I've looked at this before, and it kind of is a very flat function. So let's go ahead and graph. Here you have a basic idea of what it looks like. And so again, you'll notice, remember we said it changes direction at 1. That's where it's crossing the x-axis. That's where our x-intercept is where velocity is equal to 0. So So now if I want to find displacement, I can go to second trace, go to 7. My lower limit is 0 for my interval. My upper limit is 3. And so there it kind of shades in. And so you're going to get a displacement of negative 0.417. And so your displacement you can just write down as negative 0.417. So now let's talk about the total distance. Well, that's going to be the absolute value. So I'm going to go back to y equals. I'm going to turn it off. And then, unhighlight the equal sign. And so this guy I'm going to turn on, and I'm going to go to second 0, that's your catalog, and go to absolute value. So again, displacement is the antiderivative of the absolute value of your velocity. And so I'm going to go to variables, y variables, since it's stored in y1 already. And so I'm doing the absolute value of y1, which was my velocity function. And then I'm going to go ahead and graph so you get an idea what it looks like. Notice how everything is positive now. And so now I can do a second calc or second trace. Again, 7, which is our antiderivative. Our lower limit still is 0. My upper limit is 3. And so now you can see here's all the whole positive version. So my distance, my total distance traveled by the particle is 1.853 or 1.854. So just be ready to talk about a lot of these ideas tomorrow.